Have you ever wondered what happens when a warship fires a weapon no one can hear, no one can see, and almost no one can stop? What if the most important military breakthrough of the year was not a missile, not a jet, but a beam of light that can erase a target in seconds? If you like deep stories about power, technology, and the future of war, tap, like, subscribe, and share this with the one friend who always says real life is starting to look like science fiction. For years, laser weapons sounded like one of those ideas that always lived 5 years in the future. They showed up in movies, defense talks, and big promises. But when it came time for real combat, real navies still trusted missiles, guns, radar, and old-fashioned firepower. That is why this latest American test matters so much. It suggests the future has moved closer than most people realize. The headline sounds dramatic for a reason. The United States just tested a laser system tied to a program worth hundreds of millions of dollars. The message behind it is bigger than one test, one ship, or one flashy piece of footage. This is about a major military problem that has been getting worse fast. Modern war is now full of cheap drones, fast-moving missiles, and mass attacks designed to drain the defender before the real fight even begins. And the old answer is painfully expensive. Think about the math. A hostile drone can be built for a tiny fraction of the price of the missile used to shoot it down. In some cases, the defender may spend hundreds of thousands or even over $1 million to destroy something that cost only a few thousand. That is not just inefficient. That is dangerous. Because in war, bad math becomes bad strategy very quickly. This is one reason military planners have become obsessed with directed energy. A laser promises something that sounds almost unfair. It can hit at the speed of light. It does not need a traditional explosive warhead. And once the system is running, each shot can cost far less than a missile intercept. That changes the game. Suddenly, the side with the better beam, better tracking, and better power supply may be able to defend itself. They may defend without emptying their weapons magazine in the first hour. That brings us to the test itself. Reports and official disclosures have pointed to the U.S. Navy testing a high-energy laser system from the deck of a major aircraft carrier in realistic conditions. That alone is a huge milestone. Not a lab bench, not a concept video, not a mock-up under perfect weather inside a controlled environment. A real warship, a real target set, a real attempt to prove that this kind of weapon can function where it matters. And here is why that matters beyond the headlines. An aircraft carrier is not just any ship. It is one of the clearest symbols of American military reach. These floating air bases carry aircraft, crews, sensors, weapons, and a huge amount of political meaning. When a new weapon appears on that deck, even temporarily, it sends a message. It says this technology is no longer trapped in theory. It is being brought into the center of actual military operations. The laser involved has been described as part of a larger push toward deployable, containerized systems. That means the military is not only chasing raw power, it is also chasing flexibility. Instead of designing a weapon that can exist only inside a perfect custom-built platform, engineers want systems that can be moved, mounted, tested, and adapted quickly. That is a big deal. In military terms, portability often means speed, and speed often means urgency. Why the urgency? Because the threat has changed. In recent years, drone warfare has become one of the clearest lessons of modern conflict. Small drones can scout, distract, harass, and strike. Larger drones can carry serious explosives. Swarms can force expensive defenses to react again and again. Even if each drone is not individually terrifying, the total effect can be brutal. They eat time. They create panic. They force commanders to reveal positions. They pressure defensive systems. They turn every engagement into a cost trap. The Red Sea offered a harsh preview of this new reality. American and Allied ships faced repeated attacks involving drones and missiles launched by hostile forces. These were not abstract scenarios cooked up in a classroom. These were real operations, real interceptions, and real costs. Each time a ship used a high-end interceptor against a cheap incoming threat, the same question grew louder. How long can this continue? The question goes beyond money. A warship has only so many missiles on board. Once those cells are filled, that is the magazine, every defensive shot reduces what remains for the next wave and for any offensive mission that may follow. A ship that spends too much of its arsenal on defense can survive the first problem only to become weaker for the second. This is one of the deepest tensions in modern naval warfare. You must protect yourself without using up the very weapons that make you dangerous. That is where laser weapons look so attractive. As long as the platform has power and cooling, it can keep firing without relying on a limited stockpile. In theory, that gives commanders something close to deep endurance against small threats. Not unlimited power, not magic, but a completely different kind of sustainability. And this is the emotional core of the story. The laser is not exciting just because it feels futuristic. It is exciting because it attacks a fear that every military planner understands. Running out of missiles, running out of time. running out of cheap answers while the enemy keeps sending cheaper threats. Still, before we get carried away, we need to separate fantasy from reality. A laser weapon is not a death ray from a comic book. It has limits. It can be affected by weather, moisture, dust, and atmospheric distortion. It needs precise tracking. It needs power. It needs cooling. It may do great against some drones, yet struggle more with other targets that move faster, fly differently, or are hardened. It is powerful, but it is not all-powerful. That is exactly why this recent test matters. A real test begins to answer the painful questions. Can the system find the target quickly enough? Can it hold the beam steady? Can it damage the right point? Can it do this under shipboard conditions, where movement, salt air, vibration, and operational stress all make life harder? Every successful step is a major signal that the technology is becoming practical. Now let us talk about the money, because money tells you whether a government is serious. A flashy test can be theater. A large budget line is harder to fake. When military planners start directing major funds into high-energy laser development, integration, testing, and support infrastructure, they are not treating it as a toy. They are building a future around it. And when people hear $500 million, they should understand what that really means. It means the government is no longer asking whether this field is interesting. It is asking how fast it can become useful. The number is important, but the direction matters even more. Large increases in directed energy spending suggest urgency inside the Pentagon. Programs that sit comfortably in the research world usually grow slowly. Programs pushed by real operational pressure often grow fast. The rapid expansion of interest in lasers suggests that leaders believe the threat environment is already shifting. They are not funding a distant dream. They are trying to solve a live problem. That live problem is simple to explain and hard to solve. Traditional missile defense is excellent at destroying dangerous targets, but it is expensive, finite, and heavy. You cannot pretend every cheap drone deserves a $1 million answer forever. That path ends with depleted stockpiles and exhausted budgets. Directed energy, if it works well enough, offers a new layer of defense that can save those expensive missiles for the threats that truly require them. This is why so many experts describe lasers not as replacements for all existing weapons, but as part of a layered defense. Imagine a shield with multiple rings. At one level, electronic warfare may disrupt or confuse some threats. At another, lasers may destroy smaller and slower targets at low cost. At another, guns and missiles remain ready for harder targets that get through. The strongest defense is not one perfect weapon. It is a system where each layer handles what it can handle best. In that sense, the laser is not entering the battlefield alone. It is joining a family of tools, but it may become one of the most important members of that family because it changes the economics of defense. And economics matters more than many people think. Wars are not won by technology alone. They are won by systems that can be produced, maintained, supplied, and sustained under pressure. Quick challenge. If you want more videos that make military stories simple, hit subscribe, send this to a friend, and drop a like. A country that can defend against cheap mass attacks without burning through its best missiles gains a huge advantage. It preserves inventory. It reduces cost. It keeps options open. It also sends a message to adversaries. If your strategy depends on overwhelming expensive defenses with low-cost attacks, a much cheaper answer makes your plan less intimidating. But there's another side to that message. If the United States is moving this aggressively, others are watching and racing too. China has invested heavily in advanced military technologies, including directed energy concepts. Russia has also spoken publicly about laser systems in different contexts. Other powers do not want to be left behind. That means this story is not just about one U.S. program. It is about the beginning of a wider competition. Once a weapon shows credible value, rivals study it, copy parts of it, counter it, or try to leap past it. History repeats this pattern again and again. Radar, jets, stealth, drones, cyber tools. Every major military advantage creates a race. Lasers are now entering that same pattern, and races like this do not stay clean for long. Once militaries know directed energy is improving, they will also develop ways to survive it. That could mean harder materials, new coatings, evasive flight profiles, faster attacks, or tactics to overload the laser. Every shield inspires a new spear. Every spear inspires a new shield. And that is why the real story is not the laser works, therefore everything changes overnight. The real story is the laser has crossed a threshold and now a new competition begins. That is more serious and more interesting. Because once a threshold is crossed, whole strategies start to move. Now here's the twist most people miss. The hardest problem may not be the laser itself, it may be the ship. A high-energy laser is hungry. It needs serious electrical power. It also creates heat, and that heat has to go somewhere. This is where reality punches through the hype. You cannot simply bolt an ultra-powerful beam weapon onto any ship. The vessel needs enough power generation, storage, thermal management, and integration with sensors. Without that, the laser may remain impressive but limited. This is why next-generation warship design is so important. If future naval battles involve energy weapons, then ships must be built with that in mind from the beginning. That changes architecture, engineering priorities, and how the Navy thinks about combat power itself. In the past, people thought of armor, speed, or missiles. Now, raw electrical power may become a defining feature. Imagine what that means. The ship power plant stops being a background detail and becomes part of the weapon story. The ability to generate and manage electricity becomes combat power. The cooling system and storage become combat power. In a real sense, the future fight may be shaped by who has better energy infrastructure floating at sea. So when you hear that, the US tested a $500 million laser system, do not imagine just one machine. Imagine an entire ecosystem being forced into existence around it. Power, cooling, tracking, software, training, and maintenance. The beam is only the visible tip of a much larger transformation. And here's what makes the story intense. The transformation is happening under pressure, not comfort. The Navy is moving because cheap drones and missile saturation are exposing painful weaknesses in current defensive models. That is what gives the program urgency. It is technology pushed by fear of falling behind the threat. Now let us dig deeper into what this laser can actually do. Headlines often blur the difference between promise and proof. At its basic level, a laser puts concentrated energy on a target long enough to damage or destroy something important. That could mean burning a control surface, blinding a sensor, overheating electronics, or weakening a structure until it fails. Against drones, that can be very useful. Drones often depend on exposed sensors and lightweight structures. If they lose control, vision, or suffer structural failure, the mission is over. A laser can create that outcome without a missile. Against cruise missiles, the challenge is harder. They are faster, tougher, and give defenders less time. A laser that can help defeat cruise missiles would represent a major leap. But help is the key word. The most realistic role for many lasers is likely to be one layer in a broader defense, especially against drones. There is another advantage: speed of engagement. A laser delivers its effect at light speed. Once detection and tracking are working, the engagement process can be extremely fast. In saturation attacks, that matters. And then there is precision. A well-controlled beam can focus energy on a specific critical point to reduce waste. Of course, lasers are line-of-sight systems. Atmospheric conditions like rain, fog, and salt spray can interfere. The ocean is not a lab. It moves, shakes, and throws moisture everywhere. Sea-based success is a major step. There is also the issue of time on target. A laser often needs to stay focused on a precise spot long enough to work. Still, the potential is massive. If you cheaply defeat a lower tier of threats, you free up your best systems. In war, efficiency can decide survival. Imagine what happens if lasers keep improving over the next decade. Better beam control, power storage, and automation could turn a counter-drone tool into a broad defensive layer. This is why it is not staying inside the Navy. The Army and Marine Corps have shown similar interest. The logic is the same. Cheap airborne threats are multiplying, and traditional answers are too expensive. This is a bigger American defense story about building a future that does not answer low-cost attacks with gold-plated responses. But fielding it at scale is hard. Military history is full of powerful ideas that took too long or cost too much. Technology wins only when systems, people, and strategy grow around it. It needs doctrine and honest testing. What world emerges when major powers can defend themselves with near-silent beams at tiny cost? It updates the arms race. The United States knows the battlefield has changed. It knows cheap threats can drain elite defenses. If it does not adapt fast, the most powerful ships in the world could become vulnerable. That is why this matters. The next era may belong to those who turn energy into defense efficiently. Not just more force, but sustainable force. Sea power was measured in steel and missiles. Now another measure is rising. Who can weaponize massive amounts of energy? A laser may not announce itself. The danger becomes quieter and faster, making conflict feel more distant, yet deadly. Imagine a crew on a ship. Instead of the old explosive answer, a beam solves a deadly problem before it reaches the deck. If the system works when it matters, it could reshape the balance between cheap attack and expensive defense. But the story is only beginning. Rivals are adapting, and future wars rarely wait for perfect systems. The America test is a signal that the opening chapter of the future is already here. The question is no longer whether lasers belong, but who will learn to use them first and power them best. And if that answer arrives sooner than expected, this test may be remembered not as a curiosity, but as one of the moments the battlefield quietly changed forever.